Bismillahirrahmanirrahim. Assalamu alaikum, students. Students, today I will discuss with you chapter number 30, and 30th chapter is about nuclear physics. So, in this chapter, what we will study and what you have to remember for your final exam, this is very important. So, in this chapter, we are just studying the nuclear structure. Nuclear structure, one thing. And the second thing we will discuss the isotopes. And the third thing is the radiation and radioactivity. You can understand that it's alpha, beta, and gamma decay. And number four is nuclear decay and half-lives. Nuclear decay and half-life. And also in this article, we will discuss the activity. So these are the topics which exist in this chapter. So last time in the class, I already discussed with you about this nuclear structure, and you know very well at high school level that normally in nuclear structure, an atom, which we call an atom consists of a nucleus, and in the nucleus there are protons plus neutrons, and the electrons are revolving around the nucleus. So the entire mass and positive charge of an atom is concentrated into a very small volume that is called the nucleus. One thing. And the second thing which you should remember, just remember this one, that the radius of atom is equal to 10 raised to power minus 10 meter. And the radius of nucleus is 10 raised to power minus 14 meter. This is already calculated. So, because here our game is totally about the nucleus. So, nucleus is made up of proton plus neutron, and we call them nucleons. So, you should remember that nucleons is equal to proton plus neutron, and this is called nucleons. One thing. And the second thing which you should remember, that proton has a positive charge, and its charge is also equal to the electron, 1.6 into 10 raised to power minus 19 coulomb. And the mass of the proton is 1.67 into 10 raised to power minus 27 kg. And this value is also equal to 1 atomic mass unit. AMU mean atomic mass unit. So actually the proton is nucleus of hydrogen. So you should remember that it is nucleus of hydrogen. And hydrogen also has some isotopes, but here we are talking about 1H1, this one. So this is about the proton. And neutron, you know that it has no charge. So the charge of the neutron is 0, and the mass of neutron is equal to 1.67 into 10 raised to power minus 27 kg. And also this is equal to 1 atomic mass unit. So this is about proton and neutron. You should remember this one. But the most important thing which you should remember, the atomic number Z and the mass number A. So atomic number is represented by Z, and this is the number of protons in the nucleus. Number of protons in the nucleus. This is called Z. And the second thing which you should remember, the mass number. So the mass number is denoted by A, and this A is equal to number of protons plus number of neutrons. So this is equal to mass number. So if we want to represent any element with A and Z, how we will represent? So this is the general element X, any element X. The Z is in the lower part, this one, and A is in the upper part. So here X is the element, any element, and A, you know that this is the atomic number, and A is the atomic number, and Z is the mass number. So you should remember this symbol. And also you know that if we have oxygen, suppose it is written 816, then it means the Z value is 8 and the A value is 16. And if you want to find the number of neutrons and this element is given, then you just 16 minus 8 is equal to 8. So these 8s are number of neutrons. So in this way, you can find any number of neutrons. Similarly, if we have C613, this is the isotope of carbon, and you can find the number of neutrons. How to find the number of neutrons? Number of neutrons is equal to 13 minus 6, and this is equal to 7. So number of neutrons will be 7, and here the number of neutrons will be 8. So any element is given and you just subtract the lower value from the upper value. And similarly, we have many other examples like C614. C614. So 14 minus 6 is equal to 8. So 8 is the number of neutrons. So in this way, you can find the number of neutrons. The second thing which you should remember, that what is the isotope. So isotope, we can say that in isotope, the Z is the atomic number remain the same, and A is the mass number and it should be different. So if A is different and Z is same, then we call it isotopes, like C612, C613, and C614. These are the isotopes. So here you can see the 6 is the Z value and that is the same. But this value, here 13, here 14, these are changing. So it means A is different and Z is same. So this type of elements, these are called the isotopes. Similarly, we have hydrogen isotopes, 1H1, 1H2, and 1H3. So this is called protium, deuterium, and tritium. Okay, after this. So you should remember that most isotopes are radioactive. So when we are saying these are radioactive, it means they are not stable, and will emit subatomic particles. So when they emit subatomic particles, they will reach a stable state. So not stable, any element is not stable and it emit subatomic particles, and after that it will reach stable and we call it the stable state. So these are the isotopes. Okay, after this, now we are moving ahead in alpha decay and beta decay and gamma decay. So these are very important reactions. So when we are saying the alpha decay, alpha decay, we mean what? So alpha particles are basically helium nuclei, 2He4. This is called alpha particles. So in case of alpha particles, the helium nuclei, the helium atom, it has two proton and two neutron in the nucleus and two electrons outside the nucleus. So in case of alpha particles, I am just writing the relation that if we have X, Z, and A, and one alpha decay exists, then He24, this will emit plus. This is called parent element, and the daughter element will become Y, and that will be Z minus 2 and A minus 4 plus some energy. So it means in case of alpha decay, which you should remember, that A is decreased by 4 and Z is decreased by 2. Just remember this one because they will give in the exam they will give you this relation and they will ask anything. And you should know that in alpha decay, what is happening. This is important. Okay, after this. Now we are moving, many examples of alpha decay exist. Just read the slides. So in the second case, we have a beta decay. So in case of beta decay, there are two kinds of beta decay. One is beta negative and one is beta positive. So in case of beta negative, electron emitted. Electron emitted. In case of beta plus, positron is emitted, not proton, positron. So positron is actually the antiparticle of electron. You just remember this one. Okay. So if we have X, Z, A, and we have a beta minus decay, then we write the relation like this one, 0 plus Y. This is parent element, this is daughter, Z plus 1 and A plus some other particles are emitting, and that is, we denote it like this one, and this is called antineutrino. Antineutrino. So in case of beta negative, Z is increased by 1. This is important. And A remains same. Remains same. But in case of alpha decay, Z is decreased by 2 and A is decreased by 4. So this is called beta negative. Okay. And in case of beta plus, so we are taking an example and the same in general form, and this is beta plus. So E plus 1, 0 plus Y Z minus 1 and A plus this particle. Here is antineutrino, bar is antineutrino, but if there is no bar, then it is called neutrino. So you should remember that here the Z is decreased by 1 and A remain same. So this is in case of beta plus decay. And here it is beta negative decay. So in beta decay, there are two kinds of beta. One is beta positive and one is beta negative. So you should know that what kind of reaction exists. This is important. Okay. So in the third case, we have a gamma decay. So in case of gamma decay, uh, gamma rays are actually the electromagnetic waves. So in case of gamma decay, when a nucleus emits, this is important, when a nucleus emits a alpha or beta particle, it gets it gets excited to a higher level energy, and that is called excited state. So excited state means that if we have two energy levels, the electrons are here, and if any alpha or beta particle emits, the electrons gets energy and they will go from the ground level to the higher level. And this higher level is called excited level. So now the electrons are here. But there is a time to stay any electron on the higher level. When it comes back, they emit gamma rays. So in case of uh, gamma decay, how we can write the relation? Suppose we have X, and when alpha is emitted, then it becomes the excited. Steric mean excited state. So when we take this excited state, and when it is de-excited, so gamma is emitted and the Y is stable. Again, this is the ground level, and this is excited. So in case of gamma decay, which you should remember that if this is excited and here is Z and here is A, then after gamma, then we have no change in Z and no change in A. So it means it is excited and it is not excited. So after gamma decay or gamma release, you can understand that A remain same and Z also remain same. So this is important for your exam. They will give you like this type of reactions, and they are asking what is this reaction? It is gamma decay, alpha decay, beta decay, or any other, or mix. It can be mix up alpha, beta, and gamma. Okay. So this is the first part of this chapter. You can understand. And the next part is our, that is the nuclear decay and half-lives. So nuclear decay and half-lives. So remember about 1500 nuclei known. So total is around 1500 nuclei. So less than 260 nuclei are stable. 260 nuclei are stable. And others are not stable. So the unstable nuclei gain stability. So unstable nuclei will gain stability after releasing or emitting alpha particles or beta particles or gamma particles. Okay, then they become stable. So this phenomena is called radioactivity. So radioactivity, unstable nuclei becomes to stable. So radioactive activity is a nuclear phenomenon. Number one, it is a nuclear phenomenon. Nuclear phenomena mean all the reactions exist within the nucleus, not outside the nucleus. And also, these radiations are unaffected by temperature, pressure, or other physical conditions. Physical conditions. The third thing, radioactivity is a random phenomenon, random process. Random process. So random process mean can decay at any time. Can decay at any time. So this is about the radioactivity. So radioactivity phenomena exist in unstable nuclei, and after emitting alpha, beta, and gamma, then they will become stable. Okay. After this, now you should remember some laws, and those are called the law of radioactivity decay. Law of radioactivity decay. So law of radioactive decay, actually there is some statistical laws, but you are not studying any statistics here. I just write the equation in the words form, and then I will write the formulas. So the in the words form is this one, that rate of decay per disintegration is directly proportional to the number of nuclei in the sample. Number of nuclei in the sample. So this is the relation. So rate of decay divided by disintegration. So we are supposing that if we have delta T time and delta N nuclei are decaying, then rate of decay will be what? So it is a decay. So that's why we put the negative sign. So rate of decay is actually is equal to minus delta N over delta T. So according to this upper relation, that minus delta N over delta T is proportional to N, and N is the number of nuclei, in decay process. So if we write here delta N over delta T is equal to, then we need some constant, and that is called decay constant lambda, and this is N. Okay, after this, then we solve this equation, and N is down here and minus is here, and this minus is here, and lambda into D, delta T. So when we solve this equation, I'm not solving this equation because it is not in your syllabus. You just remember the formula. When we solve this equation after integrating, then we have this formula, N is equal to N naught e raised to power minus lambda T. So this formula is important. And here remember that lambda is equal to 1 over tau, and tau is the mean lifetime. And this small t is the time. So you can also write this relation N naught e raised to power minus lambda over tau, because T over tau, because lambda is 1 over tau. You can write in this form also. Okay, after this, so you should also remember that 1 over tau is 1 over second, or its unit is second minus 1, or minutes minus 1, or you can write its unit hours minus 1, months minus 1, years minus 1, like this one. So this is a unit of lambda, and lambda is called decay constant. This is called decay constant. Okay. After this, we should know that what is N and what is N naught. Everything should be clear, because this is important for your problem solving. N is equal to N naught e raised to power minus lambda T. Here N is called the number of nuclei left undecayed, mean undecayed nuclei. Undecayed nuclei. And N naught is called the initial number of nuclei. So undecayed and initial number of nuclei. So if you want to find the decayed, surely you will subtract from N naught minus N, and that is because initial number of nuclei mean total. So from total and minus undecayed, then you can find the decayed. Let's see further the half-life of decay. What is the half-life? Here half-life is very important, and just remember the definition and the formula. Half-life of decay. So half-life is denoted by T half. So T half mean half-life of decay mean in which half of nuclei decays and half remain undecayed. So if you have a total, suppose 100 nuclei, and from 100 to 50, this is half. It is decayed. How much undecayed? Surely 50 undecayed. How much time needs from 100 to 50? That is called half-life. How much time needs from 50 to 25? This is called first half-life. Then this is called second half-life. How much it converts into 12.5 half? Then this is called third half-life. So these are the number of half-lives. 100 to 50 first, 50 to 25 second, and 25 to 12.5 third half-life. But here you should remember another formula to find that half-life. I'm saying half-life, not saying number of half-lives. So half-life, you can find this formula ln log of 2 divided by lambda, and lambda is called decay constant. Okay. So from this formula, you can also find decay constant 2 over T half. If you know the half-life, you can find lambda. So also lambda is equal to 1 over tau. This is also formula. But it depends on the data, what kind of data is given. The next thing is the number of nuclei left. If you want to find the number of nuclei left, number of nuclei left after n half-lives, then how we can discuss this one? Suppose initial value is, always we represent it n naught. N naught means the total number. After one half-life, after first half-life, so it will become n naught over 2. And we can write this number, this value like this one, 2 raised to power 1. So second half-life mean what? It is n naught over 4. So n naught over 4, you can write it n naught over 2 raised to power 2. So the third half-life, you can write this number n naught over 8, half of this one. Half of this one mean n naught over 8. So n naught over 2 raised to power 3. So in this way, if you go for the n half-lives, then it will be equal to n naught over 2 raised to power n. So here n is representing by, small n is representing by the number of half-lives, So we will check the relation, how to find the number of half-lives also. Let's see another things first. So if we plot a graph between time and this number of nuclei, then the initial value is n naught, then it is decaying process. It will never touch here on the x-axis line. So half, suppose half is here, then what is the T half? So you can find from the graph, where is half value, draw the line and draw the line. Next is draw the line and suppose this value is 4, then you can find the second half-life. This is the first, this is the second half-life. So similarly, if you are going to this side, n naught over 8, and then you can find the third half-life from the graph. So it means if it is 100, then surely this value will be 50, and this value will be 25, and this value will be 12.5. So from the graph, you can also find the number of half-lives in this way. Okay, after this, now we have some another things, and that is the activity. So activity is actually the rate of decay or rate of disintegration. Rate of disintegration is called activity. So activity formula is, you should remember that it is lambda into n, and lambda is decay constant. You know that lambda is equal to 1 over tau. So if I put here n over 1 over lambda is 1 over tau, then it is n over tau. You can write it in this way, activity. But sometimes the formula you have to put in this way. Let's see, activity is equal to, I'm writing n lambda. N is equal to n naught e raised to power minus lambda t also. So you can write here e raised to power minus lambda t into lambda, and lambda is what? 1 over tau. You can write like this one. So it depends on the data, what kind of data is given and how you will find the value. Okay, after this, another formula which you should remember, that if you want to find the undecayed nuclei, so n is undecayed, then n naught over 2 raised to power n. So n is the undecayed, and n naught is the initial nuclei, mean the total number of nuclei. So you can say the initial divided by 2 raised to power n, and small n is the number of half-lives. So how to find this number of half-lives or and other things? So we will see in a later. And that is, I just want to discuss with you this formula. The formula which you should remember, that is T half is equal to log of 2 over lambda, or we can write 0.693 over lambda, or lambda is equal to 0.693 over T half. And the second formula, which is equal to n naught e raised to power minus lambda t. But mostly here in this case, we will not use this formula. But the other formula you should remember, that is n is equal to n naught into 1 over 2. And this is the n number. This formula is very important. So in this formula, n is the undecayed and n naught is the initial. So to find this n naught, n is what? This small n is what? This is time over half-life. Time over half-life. So n is equal to time over half-life. So it means n is what? Number of half-lives. Number of half-lives. So this is very important, and you can solve any problem with this formula. I hope that n is equal to n naught into 1 by 2 n time over half-life. So remember this one. So by using these formulas, we can solve any kind of problems. Also, you should remember that R is equal to lambda n, and also we can write that n is equal to n naught into 1 over 2 into n into lambda. Lambda is here, and this value is this one. And in this value, n naught into 1 over 2n. I'm not driving this formula. From where this formula come? leave this one, just remember this one and to solve the problems. And similarly, here lambda you can write n naught into 1 over 2 n into lambda. Lambda value is what? 0.693. Log 2 is actually 0.693 divided by t half. So this is the complete formula to find this R value. R value means the activity. So also you can use this formula. So in this way, we will solve the problems, and I hope you will understand the problems by using these formulas, and it's easier for you. Okay, so in the next video, I will discuss to solve the problems. Okay, so anyhow, see you in the next video. Assalamu alaikum.